Welcome to Science Tree channel, and today's topic is Standardize the given sodium hydroxide solution volumetrically. We will use the process of titration. Titration is a process in which the molarity of one solution is known and we have to find out the molarity of other solution with respect to that one. Okay, so let's carry out the process, and in this process first of all we will go toward the apparatus about the chemicals which we will use to carry out this practical. So let's start. Now here the number one is beaker. It is beak shaped like the beak of a bird, so that's why it is known as a beaker, and it has measurement over it, and we can say that it is calibrated so that we can easily measure the solutions in it. As we know that in chemistry we used to deal with the measurements. We used to deal with all the substances, with all the solutions in the proper measured way or in a proper measured form. So that's why we use these little apparatuses. Other than that is a conical flask. In this conical flask we can say it is a cone shaped, so that's why it is known as conical flask, and it is a narrow opening. Okay, so whenever we are stirring the solution or we are shaking the solution, the capability of moving out of the solution is low in conical flask than as compared to that of a beaker, as beaker has a quite broad opening. One of the very most important apparatus in titration is pipette. In pipette, both ends are open. We will close one end by putting sucker on it, and pipette is mostly calibrated in 10 ml. When we have to transfer the solution from one beaker to another, from one test tube to another, or from one conical flask to another, what we will do? We will suck the acid in pipette, or we can say we will suck the base in pipette. We will suck it by means of a sucker, so that we will take the amount properly in a measured way and transfer it to the other test tube. So we can say that this is the apparatus to transfer the solution from one test tube to other test tube. So this is the material required. Funnel. Yes, this is funnel, and mostly it is used in titration. We put this funnel over the burette. This is burette, and we put this funnel over the burette so that when we put the acid into the burette, it will not move here and there, or it will not fall over the other instruments or on the table. So that's why for our precautionary measures we use funnel and then add acid into it. This is an iron stand, and we use this iron stand to clamp or to hang the burette on it, and then we put our other solutions, or we can say we put our other beakers over here. One of the very most important apparatus of titration is burette. Burette is totally calibrated. It has tap on one end. Now basically this tap is used to control the amount of acid. We will drop acid one by one, drop wise into the base, and we control this dropping with the help of this tap. We will open it slowly and carefully, so that slowly acid will move into the base and the change of reaction will take place. Change of color will take place. We measure the volume of an acid which is used in titrating a base with the help of this calibration which is present over the burette. So in this way we use all these apparatus to carry out the process of titration. Now, what are the necessary chemicals which are required to carry out the process of titration? Here we are doing acid-base titration. And what we are doing for your convenience, I am telling you again that molarity of acid is known, and always remember, whenever you know the molarity of a solution, we use the term standard solution. Okay? Definitely examiner will ask from you in the Viva that what is standard solution? A very most important Viva question in the process of titration. That what is standard solution? At that time you will say any solution whose molarity is known as standard solution. Now here hydrochloric acid solution 0.1 molar which I am using. So as I know the molarity, it's a standard solution. Second thing is sodium hydroxide solution. Now it's a base, so it's an acid base titration. But at this time, I don't know the molarity of sodium hydroxide solution. I have to find it out. How? By the process of titration. So basically, this is volumetrically analysis in which the molarity of one solution is known and the molarity of other solution have to be found out. And the third thing which is very important which we use in it is phenolphthalein. Now what is phenolphthalein? It's an indicator. Okay, it is colorless in acidic medium and shows pink color in basic medium. This indicator is added into the base so that the color of base will change and we can find out the end point of our reaction just by noting the color of the indicator. So let's carry out the process. After the chemicals, after the material required, the thing which is very important, which you have to do in your exam sheets is procedure. Now for the procedure, number one thing is that you have to wash each and every apparatus. And you have to write the procedure in such a way that it's all done by you. Okay? Not like you have seen in the practical copies. You have to mention that I have done this. So I rinsed the pipette first with distilled water and then with given sodium hydroxide solution. Then I rinsed the conical flask with distilled water. I rinsed the conical flask with distilled water so that it can easily be dry out and I can easily take my solution in it. Then what I have to do? I have to pipette out with the help of pipette by sucking 10 cm cube of sodium hydroxide solution into the conical flask. Now what I have taken in conical flask? I have taken 10 cm cube of sodium hydroxide solution. And please remember that sodium hydroxide solution is a solution whose molarity is unknown. Then what I have to do? I have to add 1 to 2 drops of phenolphthalein in it. And the color of the phenolphthalein is definitely something like magenta or shocking pink. So it turns pink. Sodium hydroxide solution turns pink when we add phenolphthalein indicator in it. And the second thing which is very important, which you have to memorize, is that we don't know the molarity of sodium hydroxide solution. But we will find it out in the end of the experiment. Now I have to move towards the burette. I rinse the burette first with distilled water and then with the given hydrochloric acid solution. Why I am rinsing the burette with HCl solution and conical flask with sodium hydroxide solution? Because I have to take sodium hydroxide solution in burette and I have to take sodium hydroxide solution in the flask. So it will be better for me to rinse with the water as well as with the solutions which have to be taken in the apparatus. Then I fix the burette on a clamp stand in an upright position as I have shown you in the picture as well. And I will also clarify all this at the end of the lecture as well. Then I filled it with hydrochloric acid solution with the help of funnel, and definitely when I fill the burette, I have to remove the funnel. I use the tap at the base of the burette and allow the acid to flow in the flask. But I have to allow the acid to flow carefully and slowly so that I can easily find out the reading. Please remember, when you are adding the acid into the base, never forget to shake the flask. When you are adding acid into base drop wise, always shake the flask for the proper and thorough mixing. I keep on adding acid till the color of solution becomes light pink. Okay, please please memorize that you don't have to add all the acid into the base frequently. You have to add it drop-wise and slowly. When you add it frequently, what happens? The color will discharge in just seconds and you will not get the end point. The end point is not colorless. The end point is light pink color. And then I check whether this pink color disappears by adding one more drop of the acid. At the end, I just have to add one more drop to just check whether my end point is clear or not. So that will be the end point of the reaction. Then I have to note down the final readings. Then I have to find the difference in initial and the final reading of hydrochloric acid solution used in titrating sodium hydroxide solution. And please remember that you have to repeat the titration for accurate readings. Let's understand it with the help of Apparatus. Now this is the titration Apparatus, and in this one is burette. What I have to take in the burette? I have to take hydrochloric acid solution. And in burette, the solution which I have taken is also known as titrant. A very important Viva question. The solution which I have taken in the burette is titrant and the solution which I have taken in the flask is titrant. Now this is hydrochloric acid and this is sodium hydroxide solution. I have added 1 to 2 drops of phenolphthalein indicator in it. Then I have to open the tap in such a way that drop wise hydrochloric acid will gonna be fall into sodium hydroxide solution. With each and every dropping, I have to shake the flask, I have to stir it carefully so that the mixing have to be done in a very well way. Then I have to note the reading. Which reading? When I have start the practical, I have to definitely note that how much amount of hydrochloric acid I have taken. Then when the color of the flask solution turns light pink, at that time I have to note that how much amount of hydrochloric acid solution has been used to change the color. So that will be known as final reading. One is the initial reading. Initial reading is that reading at which I have just started the practical. And final reading is that reading at which the solution in the flask will get the end point or get light pink color. And then I have to find out the difference and use the calculations to find out the molarity of sodium hydroxide solution. Basically, I am using hydrochloric acid solution and sodium hydroxide solution, so I have to know the chemical equation. Why I have to know the chemical equation? Because to carry out the calculations, I used to know the moles, number of moles. So, memorize this equation. In this, 1 mole of hydrochloric acid is reacting with 1 mole of sodium hydroxide solution, and definitely this is the most famous neutralization reaction, and at the end we got the salt and water. Now these are the observations, and please remember you have to write the observations in the tabular form, in the data form, in the collective form. So for that it's easy to memorize, it's easy to find out the results. These are the readings of burette. Okay, that how much amount of hydrochloric acid is used to titrate the sodium hydroxide solution. So here the initial reading of HCl is 0 in the burette, but when I use it drop wise, just in titrating sodium hydroxide solution, its value goes to 10. Then I find out the difference, which is 10. The difference between the initial reading and final reading. Then I have to take the second reading. In second reading, as I have used the volume of hydrochloric acid solution up to 10, then I have to start it from the 10. So the initial reading is 10. And in titrating the solution of sodium hydroxide, it reaches up to 20. Now again the difference is 10. It means that my first reading was very good. It was right, as my second reading is also 10. Again, just for my satisfaction, I have to again carry out the process. Now, as I have used hydrochloric acid solution up to 20 centimeter cube, now I have to start the practical from 20 centimeter cube, which is the initial reading, and goes up to the final reading, that will be 30. At 30 centimeter cube, again, the indicator which discharge its colors. It will discharge its color and changes into light pink, and again the difference of 10 will take place. So I can say, after taking the mean value, after taking the average, 10 plus 10 plus 10 divided by 3, I will get volume of hydrochloric acid solution used is 10 centimeter cube. This is known as dilution formula, and this is also known as the formula to find out the molarity or the volume of any type of a solution. So here you have to memorize it. M1 V1 N1 is equal to M2 V2 N2. Now here, what are these M1 V1s? M1 is the molarity of the acid solution. We know it, 0.1 molar, so that's why I'm saying it standard solution. V1 is the volume of the acid solution, and the volume of the acid solution we find out with the help of titration, which is 10 centimeter cube. I have get the number of moles from the chemical equation N1. M2 is the molarity of the base solution, which is unknown, and I have to find it out with the help of calculation. And V2, volume of the base solution, and I have find it out with the help of pipette by measuring it, which is 10 ml. And N2, number of moles of the base. So let's carry out the calculation. So all these values which I have told you before, I have to put all these values in the formula in such a way, like we know that if we have all the categories present, we can move out the thing which we don't know. So in a similar way here, we don't know the molarity of M2, or we can say we don't know the molarity of a base. So we have to move out the base on one side and all other equation on the other side. Then we have to put the values. Again, I am telling you the values just for more clarification. M1, molarity of an acid, that is 0.1, and we know it as we are using the standard solution. V1, 10 centimeter cube. From where we get it? We get it with the help of burette. Okay, we are using the burette. We are dropping one by one hydrochloric acid into sodium hydroxide solution and noting the reading. So this is the difference between the initial and final reading, which is 10 centimeter cube. Then the number of moles is 1. Okay, for acid it is 1. Then N2, number of moles of base, again 1. And V2, volume of sodium hydroxide solution, which we have taken in flask with the help of pipette, and that is 10 centimeter cube. So we get the molarity 0.1 centimeter cube, which is the molarity of sodium hydroxide solution. So in this way, thank you so much. For more videos, keep watching. Have a great day.